be equivalent to log b of c equals a. So 3 raised to the second equals 9. So this will be log base 3 of 9 equals the exponent 2. So log 10 raised to x equals y. So that will be log base 10. So but 10, we don't write it, right? So understood that if you have log, that's 10. Okay, so that will be log 10 of y equals x. So there's a 10 here, but we don't write it if there's a 10 because log is automatically 10. So how about r raised to t equals w? So that will be log base r of w equals t. So how about y equals e raised to 3x? So how do you put this in logarithmic form? So if you have an e, so that will be equivalent to inverse. So in. So inverse of y equals the exponent 3x. Okay, so take note of that. So example 2. So convert the following equation from logarithmic log to exponential. So this will be the reverse, right? So very easy. So 7 squared equals x. So how about this one? So put this in regular form so that it will be easy for you. So log 3 of y equals x is 3 raised to x equals y. So take note, if you have log, so you have a base 10, right? So log, so which is 10 raised to the second equals y. So how about inverse c of 4? Okay, so inverse is equivalent to e, exponent 4, then c. Okay, so we will have more of this as we go on later. So let's have evaluating expressions involving logarithm. Sometimes we can evaluate log expression without the use of calculator by utilizing its equivalent exponential form. So evaluate the following expression without calculator. So change this first to exponential because it's easy, okay? So put something here. Put x here so that it's easier for us to find what's the value of that x. Okay, then change this to exponential. So that will be 2 raised to x. So that will be equals to 8. Okay, then solve for x. So make them same base, right? Or mental math. So what number raised to 2 equals 8? So isn't it 3? So x is 3. Or make it a simple 2. So 2 to the third because 2 times 2 times 2 equals 8. So therefore x is 3. So that's how to simplify. So put this again to exponential to 5 raised to x equals 25. So mental math, so what number you raise to? So to 5 to make it 25. So that will be 2, right? So how to make it a good solution? So 5 squared. So 5 times 5, 25. Then x is 2. So the third one, so log base 2 of 32 equals x. So 2 raised to x equals 32. So how many times you will multiply 2 to itself to make 32? So that will be 5, right? So make it a good solution. So 2 raised to 5. Then x equals 5. Then how about log 100 equals x? So let's say log is 10, right? So 10 raised to x equals 100. So how many times you will multiply 100 to make 10 to make it 100? So 2. So that will be 10 raised to x, so 10 squared. So x is 2. Okay, so you can try this one. So log 16 of 4, log 3 of 1, log 10, then log 6 over 136. Okay, so on your own. So then let's compare answer. So for E, so you need to have the same thing. So put an x there. So before you put it into exponential form. So that will be 16 raised to x equals 4. Okay? So make them a same base so that you can easily visualize the value of x. So 4, power of 4 for 16, 4 to the second, then times x there in the exponent, then 4 raised to 1. Okay? Then solve for x. So 2x equals 1. So x is 1/2. So f 3 raised to x equals 1. So any raised to 0 equals 1, right? So the answer there is 0. So that will be, so how do we know that one? 3x, then 3 raised to 0 is 1. Then x equals 0. So log 10 of x, so again you have a log, so that is equivalent to 10. So 10 raised to x equals 10. So they are both same here, so automatically you have 1. Then log 1 over 36, so that will be 6 raised to x equals 136. So here we need to apply and review the value of the negative exponent, right? So 1 over 36 is same as 6 raised to negative 2. So 6 raised to negative 2 is 1 over 36. Okay? So therefore, x equals negative 2. So how about if you are asked to use the calculator? So very simple. So for this one, you just look for log, I-L-O-G in the calculator. So log 9, when you press the calculator log 9, so that will be 0.9542. So I will stop here later then to give you time to practice where is log in the calculator. So log 6125, so press that in the calculator, then you will see 78, 71, then 3. So how about if you have a base? So for the base, so look for the math, then go to A, then log base. Then you can type this the way you see it. So log base of 2 equals 10. So the calculator will give you 3.3219. So same with D. So that will be go to math, A, log base, then type that in the calculator log 7, 135, then the calculator will give you 2.5208. Okay, so if you have questions, let me know. So before we go to sit work. So let's go to the application. So the good application of this logarithm is it can be used in constructing semi-log plot. Okay, so take a look at the two graphs below. So the population from 1620 to 1820, wherein the time zero represents 1620. So how many people from that period? So we can represent that using semi-log plot, like what you see. So I will explain this as we go on later. Okay, so take note of this. So this one, the y-axis can be represented as your semi-log. So like 10 to the 1 is 10. So 10 to the second is 100, then 1,000, 10,000, 100,000, so on, so forth. So, but the graph is still the same, but if you have semi-log plot, you can easily visualize the starting population. Like this one, compared to the regular graph. So do you think that the initial value of the population is 0, right? Because you cannot see it in the graph. So I will deal more of this in the next example. So take a look at this one. So this is the semi-log graph. Okay. So again, so the value of 10 to the first is it's like 10, 100, 1,000, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, 6, 7. So that's the meaning of this one. So the population data of the English Americans in the current United States for years 1840, 1860, and 1880 are given below. Plot these three additional data points on the graph above. Okay, so take note that the starting year was 1620, right? So how many years? So 1840 minus 1620, it's 220 years. Okay, so same with 1860 minus 1620, so this will be 240 years. Then 1880 minus 1620, so this will be 260 years. So how do we get the logarithmic equivalent for this one? So for the logarithmic expression, so just put this in the calculator. So log population. So type log, then 17,069,453. Then you will see 5.2322. Okay? For that one, so 2020 is somewhere 17, so close, so 7, so somewhere here, so 7.23. So that will be in this point. So a little bit closer to 6. So for 240, so log population 31,443,321. So when you press that in the calculator, so that will be 7.4975. Okay, so that will be 240, so 749, so between half. Then 260 years, so same. So put this in the calculator, log 50,189,209. So that will be 7.7006. So somewhere here now. So near to 8. Okay, so that's how to put this in the graph. So for the next one, so let's plot using the semi-log plot. So take note that 10, 1, so 1 is, this is 1, 10, 100, 1000. So meaning to say this line here is 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Then 200, 300, 400, 500, 600 until you reach 1000. So how will you represent, where is A? So 120. So 120, this is 1. So your first value is 120 is here. Because this is 10, then 20. 2, 300. Where's 2 to 300? This is 100, 200, 300. So this will be your B. Then C, 3, 2. So 3, then 1, 2. So this will be your C. 4, 15. So 4, then 10, 11, 12, 13, 15. So that will be 10, 20, right? So between. So 4, 15. So letter D. Then E, so 5, 350. So 100, 200, 300, 400. Somewhere here is your E. So very easy to grab. So let me know if you have question, then we can discuss it live on the class.